Hi, our names are Jacob and Jimmy, and this is a review and simple explanation of the node voltage method in order to solve circuits for unknown values. Firstly, what is a node? A node is an uninterrupted segment of wire of any shape. Why the node voltage method? The node voltage method can be a convenient method for solving circuits when solely using KVL and KCL isn't appearing to get you anywhere.
Generally, you can solve node voltage analysis problems with a series of steps. The first step is to assign a ground node. Normally, you want to pick a ground node that is connected to a lot of wires or is in a location where you would directly know a voltage. In this example, you would pick the bottom middle node because you would directly know the voltage at point A, because the difference between the ground, which is 0 voltage, and point A is a 75 volt voltage source. You know that the voltage at point A must be 75. A good analogy to think of this is to think of ground as ground level in terms of height, and the various nodes as mountain ranges, where each node is at a different height, but each connects to the ground. In node voltage analysis, your goal is to figure out the height of each of these mountains or the different voltage at each of the points.
The next step in node voltage analysis is to assign node voltage names to the remaining nodes. Name all voltages using the known voltages. If this cannot be done, reevaluate your ground node. Ideally, you would have one unknown V to solve for, but it's okay to have multiple. You will just have to solve for two or more unknown voltages using systems of equations. Here in the picture, our VA is known as 75 volts, while VB and VC are unknown voltages that we still need to solve for.
The third step of a node voltage analysis problem is to write the Kirchhoff's current laws for each node. When performing a node voltage analysis, you have to make sure that you start from the back of the arrow to the front of the arrow that you draw of the currents that you draw. So in this case, we'll draw the arrow from A to B, and as V equals IR, I equals V over R, the equation for I would be VA minus VB divided by 25, and we know VA to be 75, and so this equation will be helpful. If your arrow was facing the other way, you would get an equation like VB minus VA divided by 25. You would still be able to solve it, but you just have to pay attention to the direction. So that is how the A to B equation would be drawn in this case. But you also need to draw two more equations, from B to ground and from B to C. Both of these could be drawn in a similar way, and if the arrows are drawn like they are in this image, you would end up with the equations VA minus VB over 25, VC minus VB over 10. Notice that's because you're going from right to left, from C to B. And from ground to B, you would have 0 minus VB divided by 50. In order to solve this problem, you need to put all of these equations together and set them equal to 0, as you know that the total current at this node must be equal to 0 based on the way we've drawn our arrows.
Now we are left with just a systems of equations that we have made from using Kirchhoff's laws in our circuit, at which we can find the unknown node voltages. Once we find these node voltages, we can use Ohm's law, specifically the form I equals V over R, to solve for any unknown currents that we would like to know in the system by simply plugging in the respective resistance value and the voltage value that we have just solved for using node voltage analysis.
Now that you have both the currents and the voltages, you have successfully solved this circuit. Once again, the steps that you should follow to solve this type of problem is to first assign a ground node, which is connected to a lot of wires and generally a voltage source, to be the baseline 0 voltage value for your circuit. Then you want to assign node voltage names to the remaining nodes, using the ground node as a reference. Then you want to use these voltage names to write the Kirchhoff's current laws for each node, and make sure to pay attention to the direction you draw your arrows. Finally, you need to solve the systems of equations, which will either be for 1 or 2 voltage values, and then plug those voltages back in to solve for the currents.